Hi and welcome to this video for the BTEC Applied Science Level 3, and what we'll be doing is the Unit 2 Assignment 3 walkthrough. So 2 pass criteria, 1 merit, 1 distinction. And again, just starting with the passes down here. So P5, what we are looking at is actually carrying out the practical. So learners will follow instructions, safe working practices, a good level of ability when carrying out paper and TLC. So things like wearing your gloves to make sure you don't touch the paper, and you should get reasonable separation of the chemicals on there, and hopefully the amino acids actually appear on the paper when you spray it with an hydrant. If not, you're perfectly fine to repeat it, but generally at the end what you want is something that looks like one, two, three. Something that looks like this. So obviously the unknown would compare with 2 of these 3, depending upon how you've set it up. But we should have our standards there for the paper one. Then the unknown contains 2 of those 3. Solvent line should be marked with a pencil. Likewise, you should have your initial starting point there. And then, as I said, clear dots on there. If they are too big, too smeared out, just repeat it. The other bit within it, you will determine the RF values and use these to correctly identify components. So P5, do prac, get results, calculate RF, and state what's actually in your unknown. RF value is very simple to do. Just get a ruler. So for this one, middle point there. And you just do, say if that's 1 centimeter and that's 4 centimeters, just 1/4, and RF would be 0.25. And you just do that for the middle of each of the points there. Now, P6 is a little bit of theory. Learners will comment on the suitability of the techniques for separation and the chromatogram produced from each. So P6 is in here. So what we need for this is kind of how chromatography actually works and why it is able to separate these. So what you need to be talking about are things like mobile and stationary phase, the fact that amino acids are either polar or non-polar, and then with the practical that you've done, is your mobile phase the polar or non-polar, and likewise the stationary the opposite, and why the amino acids have moved up at different rates. So you need to be talking about why some of them are having more interaction with the mobile phase than others. So that one's got lots of interaction with the mobile, and this one obviously does not. But that's how chromatography can separate them out, just based on their relative affinity with that mobile phase. Now on to the merit. Safe working practices, high level of proficiency, so just do the practical well. Minimal supervision, as usual. Teachers should be able to stand back and chill out for a bit. They will be watching you. You will be getting an observation report written up, so they will be looking up every now and again. Clear separation of spots. So across here, we want to see dots that are nice and clear away from each other. That's good. Whereas if they are smeared out and we've got lots of overlap in there, bad. Just repeat the practical. As it says, repeating is perfectly fine. if you are not satisfied with the quality. So it does not matter at all if it takes you 2 or 3 goes to get this done. Learners will also comment on the suitability of the techniques for separation. To be honest, you've done that in there. Calculated RF values, again, you've done down here. And then for factors that influence separation to justify conclusions drawn about the identification of components. This is a little bit of research where what you'll need to do is actually find out which amino acids are polar and which are non-polar. So that's one of the biggest driving factors for this. But there are other things such as size. So for example, if 2 of these dots were coming out at roughly the same polarity when you Googled it, but one of them was appearing higher than the other, it could be that size is therefore letting one of them travel further. Small molecules tend to get carried easier than large molecules by the mobile phase. But it needs a bit more theory and depth for the merit bit, as opposed to the pass here, where all you're talking about is they are separated by relative affinity. Up here, you need to be saying, well, this molecule is highly polar, my mobile phase is polar, therefore I would expect it to travel further, and it's true. This one, non-polar, so it interacts more with the non-polar stationary phase. I've got 2 molecules that have got the same polarity, but one of them's traveled further. Clearly, this one's probably got a smaller size. When I looked up the molecular mass, this was the case. What you should have, therefore, with all of this, references where you're actually getting this information from. So, merit, good chromatograms, and then detailed theory. Now, distinction. Strong links between outcomes techniques used in order to give a rationale for specific improvements that could be made to the chromatographic techniques. So this is within chromatography. There's all sorts of things that you could do wrong. So for example, I could have the paper on a slant there, in which case when the mobile phase is rising up, it's obviously starting this chemical off a lot quicker than this chemical. Same as if you were having a sprint, that's unfair if one of them goes first. It could be a case of where you've got a big ugly smear on where your thumb has been on there when you've been holding the paper, in which case that's obviously going to make it very difficult to see spots that are across this side. If things are too big or smeared out, generally when you're putting your chemicals on, what you want to do is, as I'm trying to get across here, tap quickly a few times so that you get a concentrated small point, and then what you should get is a nice clear small one there. If you just tap and leave on so that you end up with a big blob of material there, then what you will generally see is a big smear up the chromatogram as well. Now, if your chromatogram came out perfectly, please say what you did well to get that. So for example, here, if you've got this and you've got all your results like this, you would talk about what we've just said there, how you've done that to get those nice, sharp, clear points. Whereas if yours look like this, then give comments for how you can improve it and turn it into this side. So the distinction, you need to be giving how you can improve it, and when you do those changes, what you would expect to see. So it gives you here 2 examples for it. I'd expect to see a couple more rather than just copying the specification out with this. So there are other ways you can improve your chromatographic technique. Google them, and then obviously just put those in as extras. And that should give you the distinction grade. Thank you.